Okay, all right, let's do this. So, next part in the lesson, right? We did the first two. Now let's try and take these from rectangular to polar form. So what happens here? If z sub 3 is 3 plus 3i. So where is 3 plus 3i in the complex plane? It's 3, 3i. So I'm right over here. So if I say what's our first move is calculate r. Our r value is equal to the modulus of z. So the modulus of z is equal to the square root of a squared plus b squared. My a is 3. My b is also 3. All right, this is my a, that's my b. So that's equal to 3 squared plus 3 squared, which is equal to 9 plus 9, which is equal to the square root of 18, which is equal to radical 2 radical 9, which is equal to radical 2 times 3, which is equal to 3 radical 2. Okay? So that is our a value. So we have to get kind of used to this as our, if we have a weird or irrational number as in r. So here r is equal to 3 square root of 2. Okay? Now we need to find what? We need to find the argument of z. And the argument of z is the rotation from the x-axis to here. So how much rotation is from here to here? And that's a little weird because in the previous examples, we had a rotation to here. We had either 90 degrees or 180 degrees or 270 degrees, right? How much rotation is here? And we need to do a little bit of a lesson here. If I were to say, look at these triangles here, right? These triangles we're very friendly with. Oh, sorry. These triangles we know, right? But where did these triangles come from? They really came from this, okay? So Mr. G kind of was a little tricky with you guys. I never showed you this before, but I said hopefully you learned this in geometry, right? These triangles are always there, and you should have picked this up in geometry. But how do these convert to these, or how can I convert these to these? So remember, if I have our unit circle, right, our radius was always 1. So the reason why we always had these lengths 1 was because of the unit circle, right? Because every triangle we made always had a hypotenuse of 1. But then how can I convert these triangles, right? How can I convert these triangles so they look like this, right? So this would be, let a equal a half. So then what's 2 times a half? It's 1. Then this is 1/2. And this is square root of 3 over 2. Because it's 1/2 times, you have 1/2 times square root of 3. So that's square root of 3 over 2. So you see, I let a equal to a half. And that's how I got my hypotenuse to be 1. And that's how I created this triangle, but I created this triangle from this guy. Okay, what about this guy? How can I make this triangle to this one? Well, I could just let my a equal square root of 2 over 2. So this is square root of 2 over 2, this is square root of 2 over 2, and this is a times square root of 2. So this is square root of 2 over 2 times square root of 2. But then this is square root of 4 over 2, and that's equal to 2 over 2, which equals 1. So we got this to be 1. And the same thing, a equals a half, would make this happen. So this is a half, this is 1, this is square root of 3 over 2. So Mr. G was very sneaky with you before, that these triangles really came from these triangles. So how can we use these triangles to calculate the argument of z, the degree of rotation from with respect to the origin to our z sub 3? So here we need to see that, what is the length, if we go back to this, hold on, let me do this here. All right. Which one of these triangles are we going to use? Notice that if this is 3, right, the distance from here to here is 3. What's the distance from here to here? It's also 3. So notice we're making a triangle, we're making a triangle, We're making a triangle like this. It's 3, 3, and this one has to be what? 3 root 2. And we calculated this. This is my r. This is 3 root 2. And if I have 3, 3, 3 root 2, which triangle am I using? I'm using this one. Bam. So now that I know I'm using this triangle, what is the argument of z? It's a 45-degree rotation. So our theta here is 45 degrees. And then let's just finish it up. How would this look like if I have r times cosine theta plus I sine theta, right? So this has to be 3 radical 2 times cosine of 45 degrees plus I sine 45 degrees. And this will equal 3 plus 3i. Well, let's check it. What is cosine of 45 degrees? It's square root of 2 over 2 plus I times square root of 2 over 2. And we're going to multiply this by 3 root 2. So this is the check. Check that this actually equals this. If I multiply this to this, I do get, what is 3 root 2 times root 2 over 2? This is, we're just doing this to this. This is 3 root 4 over 2, which is 3 times 2 over 2, which is just 3. And this 3 represents this 3 here. And then how do I do 3 times this? It'll be the same exact thing. So it is 3 plus 3i. All right. Let's try and do another one together. Here, these are our very nice triangles we're going to learn from now on. Here, let's look at the next one. Let z sub 4 equal 2 minus 2 radical 3i. What I want you to do is try and do this question on your own. Okay? What is my... Right now, if you want to see the solution, what is r equal to? Well, r is equal to the modulus of z, which is equal to the square root of 2 squared plus 2 root 3 squared. But then that's equal to square root of 4. And what is 2 root 3 squared? That is equal to 2 root 3 times 2 root 3, which is equal to 4 root 9, which is equal to 4 times 3, which is equal to 12. So this 2 root 3 squared is just 12. So this is 4 plus 12 is square root of 16, which is just 4. Okay? So now we know that if we graph this, 2 minus 2 root 3i, where is that? 2 is over here. Where is 2 root 3? It should be, oh boy, what is that equal to? Let me get a calculator, hold on. Thingamajiggy. 2 times square root of 3, is it 4 point something? Oh no, it's 3.4. So I know I have to go a little bit after the 3. So I know this is my z sub 4. So I know that the distance from here to here is 4. But then the question we need to do is, what is the argument of z? What is my degree of rotation? So if I start here to here, it's saying how much degree rotation did I do? Well, we need to figure out which triangle we're going to use, right? Well, let's see. If I'm making my triangle, right, I know that the distance from here to here is 4. What is the distance from here to here? That has to be 2, right? Because I'm going 2 to my right. And I'm going, how much am I going down? This is 2 radical 3. So now which triangle, just by looking at it, let's see. This should be, which triangle will it be? I want to pause the video and I want you to think about it. Which triangle here will represent this triangle here?